This is 5.5, rational exponents and radicals. Now, a radical is the inverse operation of an exponent. And we're going to basically go back and forth between exponents and radicals as we go through this lesson. I'm just going to introduce what this is. And right here I have an example of a radical. The whole thing would be called a radical. And there are parts of it we need to know. Okay, this part inside is called the radicand. The radicand. Okay, now you can live a long and fruitful life without having to know that, but that's what it's called. The index here, the index is 4, which is here, and that number is telling us what root we're taking. So that would be the fourth root of 8 squared. And one more thing we need to know about a radical is when we see this sign, we're actually taking the principal square root, the positive square root. When you take the square root of a number, let's say you take the square root of 4, well, the answer is 2 and negative 2. But if I see that, the radical sign over 4, that's only equal to the positive square root. So we're just leaving the negative square root out of this. So that is what principal square root is. And that pretty much sums up our introduction. In our first set of examples, we are simply finding roots of numbers. We're going to look at each of these radicals and just answer it. Okay, it will be the positive square root because we see the radical sign here, not the negative. So this is the cubed root of 125. So I'm looking for a number that multiplies to itself 3 times to get 125. Well, you know, this ends in 5, so it kind of gives it away. This is 5 because 5 times 5 times 5 actually multiplies twice, but it's 3 5s. Equals 125. So if 5 times 5 times 5 equals 125, the cubed root is 5. So our answer is 5. Okay? Look at number 2. The fourth root of 16. So 4 numbers, all the same number, multiplied together, that gives us 16. It has to be a pretty small number if I multiply it. If I've got 4 numbers multiplied together, and that number is 2. Because 2 times 2 times 2 times 2 is 16, then the fourth root of 16 is 2. You could also think of the fourth root as taking the square root twice. The square root of 16 is 4, then the square root of 4 is 2. That gives us the fourth root of 16, which is 2. The third root of 27, well, I'm looking for a number, 3 numbers multiplied together that gives us 27. Again, it has to be a pretty small number, and that would be 3, because 3 times 3 times 3 is 9 times 3, which is 27. The third root, the cube root of 27 is 3. Okay, the fifth root of 32. Well, that's a bunch of numbers to multiply together. 32 is a pretty small number. It's an even number, so I'm betting it's 2. So if we have 5 2's multiplied together, and I multiply all those, I should get 32. So the fifth root of 32 is 2. Okay, looking at number 5, I've got the third root of 64. Third root of 64. So I know the square root of 64 is 8, so the third root of 64 is going to have to be smaller. And it's an even number, and we're going to say, I'm pretty sure that's 4. So if I multiply 4, got 3 4's multiplied together, that is 16 times 4, which is 64. So that's right. The third root of 64 is 4. Okay, here, and this is just the square root. Now, if you just see a radical without a number, it is assumed to be the square root. This one has a 2 there, but it may not have a 2, okay? So if you don't see a number, it is the square root, and the square root of 36 is simply 6. That takes care of example 1. We're going to be converting these expressions to radical forms. We're going to be going from exponent form to radical form. So if I look at this, the 12 has an exponent of 1. If we're going to radical form, the 12 is certainly not going to go in here. It's going to go out here. Okay? And it still has an exponent of 1. If we want to have an exponent of 3 halves, a rational exponent, this bottom number is the index. And we learned that the index goes here. The top number is the exponent that goes with the radicand. The whole thing is the radicand, a to the third. So a to the third goes inside, and the index goes here. But since this is assumed to be the square root, I do not need to put a 2 there. I guess you could, but it's not needed because that is square root. Okay, number 2. Now notice here, if we distribute this, we should get 64 to the 4/5 and a to the 4/5. they both have rational exponents. They will both go inside the radical sign. So we're going to do the radical sign here. The index is 5. They have to have the same index if they're going under the same radical sign. And inside they're going to have an exponent of 4 each. So 64 to the 4th, a to the 4th. This is not rational, so we're not going to figure out what 64 to the 4th, the 5th root of 64 to the 4th is, or do this. I'm just going to leave it like this. Okay, next one. We have a to the 5/6. Again, the top number is the exponent, the bottom number is the index. Radical sign here. We're going to put a to the 5th inside, and the index is 6. So it's the 6th root of a to the 5th. Moving on here, only the x is affected by this 1/3 exponent. The 5 is not. Okay, so we're going to put a 5 here, square root sign here, x there. Now the index is 3, which goes here. The exponent is 1. It's not needed. It's assumed it's a 1 anyway. So there's our final answer, 5 times the cubed root of x. In the next one, the 54 has a 2/3 on it because you are distributing this exponent to both of those. And then we have y to the 2/3. Now, the index on both of those are the same, so they can both go under the same radical sign. The 3 goes here because 3 is the index for both. Inside, I've got a 54 and a y. They both have an exponent of 2 inside, and that's number 5. Next one, number 6, we've got 72x to the 1/2. We're going to put this here and here. Okay, 72 to the 1/2, and then x to the 1/2. They both have an index of 2. You can put them in the same sign, same radical sign. We're not going to put a number there because it's assumed to be the square root. So it's just 72x inside the radical sign. In example 3, we are actually going from radical to exponential. Okay, we're going the opposite direction we did in the last examples. So I'm going to write the b with an exponent. That kind of takes care of this. So when I write that, if it'll write, I've got b. Okay, now this is the exponent, the index. The index is the denominator, the exponent is the numerator. So it's b to the 3/5. That's how you write that. And you're done. That's it. Moving on, I'm going to go ahead and write this simplified. I can take the cubed root of 27. I know the cubed root of 27. I know 3 times 3 times 3 is 27, so the cubed root of 27 is 3. I want to write that like that. I'm going to put the d there. Again, that's the index is the denominator, that's the numerator, so it's d to the 5/3. 5/3. Moving on. Let me see if we can, now we'll scroll up in a second. Okay, I've got x, denominator, numerator, so 2/3, x to the 2/3. Okay, here the 12, nothing's going on with the 12. It's got an exponent of 1. We leave that alone. Put the x beside it. Exponent of 4 over 3, so we get 4/3 for the x. Let's scroll down just a little bit for these last two and clear the page. There we go. Let's get this. Okay, so it's a square root of 4y5. Well, I know it's a square root. You don't see anything there, so it's a square root. I can take the square root of 4 and get 2. I don't have to put any exponent on there because I took the square root. I basically took it out of the radical sign. So now I put the y there, and it has an exponent of 5 with a base of 2 or an index of 2. So it's y to the 5/2. Okay, moving on. Last one in this section. The 4th root, I do happen to know this, okay? So the 4th root of 256, I know the square root of 256 is 16, and then the square root of 16 is 4. So 2 square roots gives you the 4th root. So this should be 4. The 4th root of 256 should be 4, so because 4 times 4 times 4 times 4, 16 times 16 should be 256. Okay, so when I take this out, I take the 4th root and I take it out. It no longer has any kind of an exponent here. It's outside. I already evaluated it. It's done. Okay, now I take the a, and then it's going to be 8 over 4, but that simplifies. So really my answer is a2. 8 over 4 is a2. Okay, so we went from 4a, 8 over 4, to 4a2. With the next set of examples, we are going to convert to radical form. Convert to radical form. It's just going to take us a little bit longer to get there. So I want to simplify this first. I'm going to multiply like things together. So 3 times 8, I get 24. Okay, and then x 2/3 times x 2/3. Well, when you're multiplying bases, when you have the same base you're multiplying, you add the exponents. So I should get x 4/3. Now let's put this in radical form. I'm going to keep the 24 out, and I'm going to put the x inside. The 4 goes here, the 3 goes there, and that is in radical form. Not a big deal. You got to clean this up a little bit and then put it in radical form. Not that bad. So here we're going to simplify this. I've got x to the 3/4 times x to the 1/2. I have to add these exponents, so they need to be common denominators. This 1/2 is really 2/4. So 2 plus 3 is 5. I get x to the 5/4. Okay, radical form. I'm going to put an x there. The top number is the exponent, the bottom number is the index, and that's it. Let's clear this and scroll up just a little bit and get these next two here, or next four. Here we're going to take this and distribute it. I like to say distribute, it's probably not proper, but I like to say that x to the 1/5, y to the 1/5, and then we get y to the 2/5 in the other parentheses. Okay, these two y's go together. You can add them together, add the exponents because they're being multiplied. So I get x 1/5 and y 3/5. So again, as long as they have the same denominator, we can put them in under the same radical sign. So we put an x here, a y here. They both have a denominator of 5, which goes here. The top number is the exponent of 1 on the x, which I'm not going to write, exponent of 3 on the y. Okay, and that one's finished. Here we're going to simplify a little bit. We're going to put the 1/2 on both. 1/2, when you do an exponent of 1/2, that means the square root. Okay, so if I put the 1/2 on the 25, that means the square root of 25, which is 5. I'm going to go ahead and simplify it. X gets a 1/2 on it, like that. Okay, here, when I put the 1/2 with the 64, that means the square root of 64, which is 8. So I've got an 8 there, and x gets a 1/2 here. Everything's being multiplied together. So the coefficients I multiply, I get 40. The exponents I add. Okay, I'm multiplying x to the 1/2 times x to the 1/2, but you add the exponents. I get 2 halves. Right? 1/2 plus 1/2 is 2 halves. Well, that simplifies to 40x. 2 halves equals 1. Okay, so 40x is my final answer. Here we're going to just distribute the 1/2 on the 16 and the x. So I should have x 1/4 here, 1/4. When I distribute this, that is 16, the square root of 16, which is 4. The 1/2 goes on x, that means x to the 1/2. Okay, so 1/2 here, 1/4 here. I need to add these, so I need a common denominator, so it's going to be fourths. So this is going to be 2/4 again. I'm just going to write over that. So I get 4x to the 1 plus 2, 3/4. Okay, in radical form, the 4 stays outside, the x goes inside, the 3 goes here, the 4 goes there. Okay, moving on. Here, we've got a 4x 2/3, and here we're going to simplify this a little bit. I'm going to put the 2/3 here and here. Now let's think about the 2/3 on the 27. Let's take that to the side and see if we can do anything about that. I know the bottom number is the root, the top number is the exponent. I know I can take the cubed root of 27. We did that earlier. Cubed root of 27 is 3, because 3 times 3 times 3 is 27. The top number means to square that. So if I take the cubed root of 27, I get 3, and then square it, I get 9. So if I simplify this, 27 to the 2/3 is 9. Okay, and that's x to the 2/3. So I have, over here, I have 4x to the 2/3 times 9x to the 2/3. So I should get 36x to the 4/3. We are simply adding. Okay, simply adding. Now let's write that in radical form. 36 is outside the radical because there's not an exponent on it. Make a big radical sign here. We put the x inside. The top number is the exponent. The bottom number is the index. 6 more problems should finish our lesson today. We're looking at example 5. So it says write each expression in exponential form, simplify when possible. Okay, let's look at the first one. We're going to put each part here in exponential form. So that the first one's going to be x to the 2/5, and this is going to be x to the 1/5. Now the question is, can I do anything else to this? If they were being multiplied, yes, I could. I could add the exponents. But these are being added. And because they're being added, they have to be exactly alike to be put together. So I cannot do anything else with this. I have to leave it like this. Now, if this was x to the 2/5, like this one's x to the 2/5, I could add those together and make it 2x to the 2/5. But they're different exponents, so I can't really do anything with them. I have to leave them like that. Okay, moving on. Number 2, we're going to have 2y, and that's a 1/4. 1/4 plus 3y, 1/4. Notice here, exponents are the same. Variables are the same. So y to the 1/4, y to the 1/4, these are like terms. I can add them. So I get 5y to the 1/4. Just add the coefficients when you add like terms. Okay, let's clear the page, move down, take care of these last four. Last four. Okay, here I'm going to simplify this a little bit. I can take 27, I can take the cube root of 27 because I know it's 3. By now I should know that's 3. And I want to take the x out. I've got to write it with a 4 on top and a 3 on bottom. Okay, so it's x to the 4/3. Minus, now I can take the 4th root of 81 because I know the square root of 81 is 9 and the square root of 9 is 3, so the 4th root of 81 is 3. That'll be there. And now I've got x to the 1/4. X to the 1/4. I can't subtract these at all. I could factor them. I'm not sure that's going to do us any better. So we're just going to leave it as is. These are different exponents. That's 4/3, it's 1/4. These are not like terms, so we're going to leave it as is. Number 4, we're going to square. Actually, let's look at this. Let me take it out here, and then we'll simplify it. This 2 goes here and here. So I've got 8 to the 2/3 and x to the 2/3 minus, okay, 243 to the cube root of 243 is, okay, that's going to be 3. Because 3, if you multiply 3 5 times, you get 243. So the 5th root of 243 is 3. We're going to go ahead and do that. And we get y to the 4/5. Y to the 4/5. I think we can go ahead and simplify this, okay? If I take the cubed root of 8, I get 2. And then if I square 2, I get 4. So the cubed root of 8 is 2, because 2 times 2 times 2 is 8. And then squaring 8 gives me 4. Okay, so I should be able to write it like this. To the 2/3 minus 3y to the 4/5. These are not like terms. You can't do anything else. We're going to leave them just like that. Okay, 2 more. We're going to write x to the 2/3 times x to the 4/3. I can do something here because this is multiplication. I can add the exponents. The bases are the same. So we get x to the 6/3, which is equal to x to the 2nd. Okay, done with that. Let's write all these out in exponential form. Y to the 2/5 times y to the 1/5 times y to the 3/5. You're multiplying. They all have the same base. That means you add the exponents. And when we add, we get 2 plus 1 is 3 plus 3 is 6. Y to the 6/5. And that's going to be our final answer. And that sums up this lesson.